Hello friends, this is Chellas Kachunar. So welcome to Six Sigma video series. So in this video we'll learn about lean manufacturing basics. Friends, let's learn and understand few lean terminologies. So Umac in 1990. So he is the person who introduced the word of lean in his book The Machine That Changed the World. And value, the value is defined by a customer. So always in value of any product or anything is only defined by customer. Second terminology is takt time. So the available production time divided by customer demand is called takt time. And throughput time is total actual time taken for a product to be produced is called throughput time. So from starting of the process till end of the process, including inspection and all thing, is total is called throughput time. And process flow, it explains the flow of the process in a simple format. So value stream map we'll see in further slides in detail. It's created to identify all activities of manufacturing process. So spaghetti diagram is the same way, but it is used to describe the flow of people and material and information. Now let's learn about some metrics of lean manufacturing. So always people get confused with four different timings: cycle time, throughput time, lead time, and takt time. So they will get confused with these four terminologies. So let us understand the basic about these particular four terminologies. So we'll start from cycle time. So cycle time is the single piece production time. So you can say mathematically in such a way, net production time divided by number of units produced. This is purely process. One unit processing time is called cycle time. So second one is throughput time. So throughput time is, it's not a single operation. It is from the starting. You can see from the B, from the storage till final storage, after production, FG part storage. Till that time, all cycle time of processes and waiting time, all put to inspection time, all put together is called throughput time. So it does not include anything transport outside the organization and other FG storage and other things, but includes all operations, wait time between operations and inspection time, all put together is called throughput time. Third one is lead time. Lead time is the time from the order, customer ordering to delivery. The complete time is called lead time. So maybe after that, even you need to order raw material and purchasing raw material and receiving raw material and storage, and in your in-house all operations, inspections, and the finished goods storage, and creating an invoice and transporting to the customer end and delivering it. So all put together is called from the customer ordering to till your products delivery to the customer. Yet the complete time is called lead time. So final one is takt time. Takt time is available time for production divided by number of units required. For example, your available time for a production of any product is 100 minutes. So if a customer want 50 products in that time period, so I mean the day, that means your takt time is 2. It's complete, I mean simple division of available time divided by customer requirement, customer demand is called takt time. So normally takt time and cycle time should be equal or nearby. In case cycle time is high and takt time is low, that means so you will not able to meet the customer requirement. So in the same case, takt time is more and cycle time is less. In that case, what would happen? You will produce excess parts and you will make it into inventory. We just learned some interesting tool is value stream mapping, VSM. It's heart of lean manufacturing. So I'll give you some basic example of value stream mapping here, and I'll make 2-3 examples in separate video so that you will learn and apply this tool in all your practical processes and a practical work environment. So I just mentioned different symbols over here, and along the symbols I just mentioned the red color. So what this particular symbol used for? So like first you can see source, supplier or customer, this type of small rectangle with half triangles used, and for finished goods flow the arrow is used, and inventory is a triangle, and push system is the arrow with in intermediate black color is used. For process is complete, just triangle is used with the boxes, and information flow is simple arrow, and other than that a few terminologies, and the cycle times like cycle time and lead times are mentioned in the bottom with the inverted boxes. So these are the symbols basically used in value stream mapping. So we'll understand this particular value stream mapping. So from is complete manufacturing of a single part. It is having machining process and heat treatment process, and after that painting process. These all three processes are being done at in-house. It is in one manufacturing unit, and raw material is purchased from outsourced supplier. So afterwards, after processing all these three processes, it is shipped to customer. So now first we will understand the information flow first. So customer is giving a order. So that is that information is flowed to supplier planning department. So from there, that information is given to RM supplier. From there, again machining cell, heat treatment cell, and painting area. These informations are floated the requirement of a day. So now this is the information flow. So coming to the material flow, from RM supplier to it is coming to supplier end, and it is getting inverted, and there is an inventory. It is kept for a 5 days inventory. So from there it's a push. It's pushed from the stores. So it is going to the processes like machining. So cycle time is 20 minutes to complete the only process. Cycle time is 20 minutes. So changeover, if there is any product or model to be changed over in this particular process, it takes 40 minutes to change the operations, change the setups. So uptime of this particular machining process is 75% after the all losses, wastes, rejections, all after deducting all, uptime of this process is 75%. So next, again it is kept for a 2 days inventory, and then it is moved to heat treatment process. Cycle time is 35 minutes, and changeover, setup changeover is 140 minutes. Uptime is 85% in this heat treatment process. Then it is kept for a 1 day inventory, and then painting process. Cycle time of 60 minutes. Changeover time is 120 minutes if you want to change any painting process, any other models. So it takes 120 minutes, and uptime of this particular process, complete process, is 70%. And further, it will be just moved to a finished good inventory that's kept for 3 days inventory. Then it is shipped to customer. So these inventories are buffered inventories created by supplier based on the volume and requirement on weekly basis. So this is a simple in this single diagram. Why it is called value stream mappings? Because in this single diagram you will able to understand complete process flow in the diagrammatic way, and all the cycle times, all the data, how much time it is required for each and every process and storage. So all will be conveyed in a single map. So in this, for a person who is reviewing it, he can understand the person, and third person who is not involved in the operation, he can just understand the complete flow in an easy way. And by this data, person can understand where the loss occurs, or where waste occurs, or where unwanted material storage or lead time is occurring. So by that he can analyze the things, and he can make an improvement out of that area by seeing this value stream mapping. So by the bottom, just like lead time is mentioned, like from the starting lead time already we learned, it's from the time ordering to delivery. This complete cycle time is called lead time. From customer ordering to delivery of the product to the customer is the time called lead time. So here all lead times are just calculated in, based on the process and storages. So cycle times also calculated based on the processes and cycle time. So lead time is coming 11 days, and cycle time of this complete process, that is throughput time, you can say even, it is coming 115 minutes. So nearly it's a 2 hours of cycle time, 2 hours of throughput time. So this is complete value stream mapping. So let us understand benefits of. So like I explained, seeing the complete process flow in a single page, identifying sources and location of waste, we already discussed, providing common terminology for process, just all symbols, all terminology standard for all processes all across the world. So the language, communication language is common, and helping to make a decision about the flow. The process flows can be defined, can be rearranged, and providing a blueprint for a lean ideas. Lean ideas is a further step to eliminate the waste. So for that, this is the base blueprint, and understanding the linkage between the information and material flow, and find out the effects where all effects are just more. So the balance, you can do the further actions, and presenting the overall view to the management. So these are the benefits of value stream mapping. There is a difference. There are spaghetti chart. You can see the right side. It is similar to value stream mapping. So spaghetti means like a noodles type of appearance it gives. So it is also conveys material, information, and resource flow also. So all these flows are mentioned in this spaghetti chart. So this is similar to value stream mapping. Only difference between these two charts are, so value stream mapping is having a complete details, even cycle times, changeover times, and all information, lead times of each and every processes, and all time durations, all informations also mentioned in the value stream mapping, so that further calculations, further analysis, or reduction action planning, that can be done with the value stream mapping. But in spaghetti chart, it's only the schematic view, only diagrammatic view is given. So there is no timing and other information given. So these are the difference between these two charts. In some areas only schematic, only diagrammatic view is required. So you can use the second one. Thanks for watching. Hope you learned basics and about lean manufacturing. So please mention your expectations in this comment section so that I can cover in forthcoming Six Sigma series videos. Thanks.